Please tell me, what does this data set about? And today we will be implementing logistic regression, random forest classification, decision tree classification on the same data set. All right? Yeah. So looking into the data set, can you please tell me, what does this data set represent? What are we supposed to do with this data set? This is the data set of women patients who are pregnant, and this data set tells whether that person is having diabetes or not. So predicting diabetes during pregnancy is very crucial, guys, because once diabetes gets attacked during pregnancy, then that will be the lifetime problem for a women. So especially when they get diabetes during pregnancy. So that's the reason we are creating a machine learning model which will tell whether the person will get affected with the diabetes or not priorly. Okay, so that's what we're gonna do it right now. Fine, whether he has diabetes or not, that's what we're gonna predict. So here we have how many pregnancies she has, what is the glucose levels she's maintaining, what is the blood pressure she's having, skin thickness, does she take insulin, and what is the quantity of the insulin that she'll take, what is the body mass index of her, and diabetes pedigree function, and what is her age. So based on these parameters, a machine will tell whether the person will have diabetes or not. All right, so let's get into the practical approach. All right, so please open Jupyter notebooks, everyone. So guys, everyone open your Jupyter notebooks. So have you opened your Jupyter notebooks, guys? Shall I start? In the classification algorithm building, there will be a slight change when compared to regression algorithm. I mean, while predicting the accuracy. Okay, so today I'll just showcase the practical implementation of how to check the accuracy and all, but tomorrow I'll tell what are all those terms mean. All right, so first I'll write what are all the steps that are needed for the classification problem. I mean, for building the model for classification problem. So as usual, first one is importing the libraries. Second one is read the data set. Third one is apply pre-processing techniques. Train the algorithm. Test the algorithm. Find the accuracy of the algorithm find the confusion matrix. Eighth one, find AUC and ROC curves. Ninth one, random value predictions. So can you please tell me what is the difference between regression algorithm and the classification algorithm after, like, till how many points it is similar, and what are all the different points that came for the classification algorithm? Can you please tell me? Yeah. So in classification algorithm, the only difference that you find is like finding the confusion matrix, finding the AUC ROC curves. So for today, we will just see the programming part of AUC ROC curves and confusion matrix. But tomorrow, I'll tell you what is the theory behind it. What is the theory behind it, and how do you calculate this accuracies as well as AUC ROC curve. All right, guys. So here in the accuracy also, for regression, what is the class that we have used for finding the accuracy? It is R2 underscore score, right? But for classification, it will be accuracy underscore score. So for regression, it is R2 underscore score. For accuracy, it is accuracy underscore score. So tomorrow, I'll also tell how to find this R2 underscore score and accuracy underscore score. All right. Madhukar, I didn't get your question. Can we use confusion matrix in random means? All right, guys. So these are the steps of classification algorithm. So shall we start building, guys? So first one, import numpy as np, import pandas as pd. Next, reading the data set. So I'm just giving the name as data set is equal to pd dot read underscore csv of diabetes dot csv. So I've read the data set, and let's see what are all the values that we have in the data set. So here I have pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age, and diabetes is the last column. Right. Now, so do we have do we have to apply label encoding for this data set? Do we have to apply label encoding for this data set? Yes or no? Can I please know why it is no? Yes. we do have string data in diabetes. So yes, you have to do it. All right, because it has pos or neg. Yes or no? So first of all, let's check whether there are any missing values or not. All right. Dataset dot is null dot any. Until here, guys. Yes. Now the next step is to convert the diabetes into integer encode. So from sklearn dot preprocessing import label encoder LE is equal to label encoder. So data set of diabetes is equal to LE dot fit underscore transform of data set of diabetes. Yes. My data got converted into integer encoding. Now, is there anything that we have to do one hot encoding here? No need of one hot encoding, right? So let's directly jump into splitting of X and Y. So what are all the columns which are considered as inputs and what are all the columns which are considered as outputs? Can you please tell me? So it's from 0 is to 8. So let's see whether that is correct or not. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8. That's really good. So all rows, comma, 0th column to 7th column. So if you want to grab 7, then you have to give it as 8. In the same way, all rows, comma, 8 is to 9. So I want to grab the 8th column. So just execute that. So here X and Y got created. Now, the next step is to split the data into X train, Y train, X test and Y test. So from pre-processing sklearn dot model underscore selection import train underscore test underscore split. So X underscore train comma X underscore test comma Y underscore train comma Y underscore test is equal to train underscore test underscore split of X comma Y comma random underscore state is equal to 0. So my data got converted into X train, X test, Y train, and Y test. So let's see what is this X train shape. So the shape of X train is 6, 14, and 8 columns. 6, 14 rows and 8 columns. All right. So in classification, there should be the need of feature scaling. If the values are not in a proper range, then there will be some sort of confusion for the machine and it will misclassify it. If it is yes, then it will say it is no. I mean, for suppose if the values, if the observations should be yes, then the algorithm will say no. If the values are no, then the algorithm will say yes. So to avoid that, we have to scale all the values to a particular range. So before that, let's see what is this X train looks like. So if you see here, you have 7.0, 1.5, 7.8. So these are all the values of your patient's parameters. Now let's convert them into one scale with the help of feature scaling. From import standard scalar. X underscore test is equal to X underscore test. So just execute this. Now see your X underscore train. Everything will be into a particular range. So if you see 7 got converted into 0.9, something like that, right? So feature scaling is used to convert all the data into a sample range. So this is what all about data pre-processing steps for classification. So done till here, guys, everyone? Done till here? Yes. Now let's apply logistic regression algorithm. So how do you put that? From sklearn dot linear underscore model import logistic regression. Logistic is equal to logistic regression, then logistic dot fit of x underscore train comma y underscore train. So I am training my algorithm. So I've given my logistic regression as wrong spelling. All right. So now my data got trained. Now let's predict the value. That means test the algorithm. So now how can you test it? With the help of predict function. So y log L pred is equal to logistic dot predict of x underscore test. X underscore test. Now let's see lpred. Lpred, it gave all ones. Let's see y underscore test. So if you see, all the values are misclassified by the algorithm. Have you seen this? All the values. See here, the only first value is correct. Remaining all, these two are wrong. This is correct. These two are correct. So have you seen this? When you compare your lpred and y test, you can see everything is 1. It predicted as yes only. All the values it predicted as yes only. But in the data set we have ones and zeros. So let's see the accuracy now. The accuracy should be somewhat less, but let's see whether it is less or not. For that, until here guys, until here, understood till here? Okay, you got ones and zeros only. Maybe my algorithm didn't predict properly. I told you, right? It's not mandatory that your accuracy and my accuracy and your data set and my data set will be same. So we are taking random state is equal to 0. So my rows will be considered different and your rows will be considered different. So it doesn't matter that, I mean, it doesn't. Okay, fine, Kavya. So if you get ones and zeros, then that means it gave some sort of correct predictions. But here for my thing, everything is wrong. It gave all as ones. So I'm putting that code to everyone, logistic regression code. You can use it. Guys, done till here, everyone? Yes. So now let's see what is the accuracy that I got and what you got. So from metrics import accuracy underscore score. So L accuracy is equal to accuracy underscore score of y underscore test comma lpred. Y underscore test comma lpred. Now let's see L accuracy. So see, the accuracy that I got is 30%. So what is the accuracy that you got, guys? What is the accuracy that you got? Guys, are you not doing it parallelly? Oh, Nitya got 79. That's really good. So I'll just restart the kernel and again run it. Let's see whether I'll get good accuracy or not. So good, everyone got very good, nice accuracy, but my data is not properly getting trained. This is also differs because of the Thank you so much. Then now my algorithm, thank God, at least I got 79. So here I've done standard scaling to X test. I've given a wrong variable, guys. Sorry. So have you seen? See, if suppose I don't standardize the values, I got all the wrong answers. Yes or no? I got all the wrong answers. But after giving the proper standard scaling value, I got it. I got the correct answers. Thank you so much for your observation, Shravanti. Not Shravanti, Kavya. Thank you so much for your observation, Kavya. All right, so even I got 79%. Now for classification, this accuracy is not sufficient for saying the model is very great. So you have to also calculate area underscore under curve as well as receiver operating characteristics. Area underscore curve as well as receiver character operations or operistic something. So here AUC is area underscore under curve, ROC is receiver operating characters, receiver operating characters. So let's calculate that ROC and AOC, but before that there is another one. What is it? It is confusion matrix. So first let's find the confusion matrix. So what is this confusion matrix? Tomorrow I'll tell you, but remember you have to calculate the confusion matrix for the classification algorithm. So from that confusion matrix only you will be getting this accuracy, you will be getting AUC curve, you will be getting the ROC curve. All right, so let's see how our confusion matrix looks like. So from sklearn.metrics, import confusion matrix. Confusion matrix is also found between y-test and LPRED. All right. Let's see this CN. So here you got 94, 18, 29, 13, right? I'll tell you what are all this, but tomorrow you'll get a very good clarity. So how many until here, guys? If you're done, then I'll move forward. Yes. So if you count all the values in this matrix, you will get the count as maybe 94 plus 13. Okay, 154. All right. So you have 154 questions to that. These are the 154 test questions. Your model gave 154 answers and your key paper also has 154 answers. All right. Out of which 94, this one is there, right? 94 are correctly predicted as yes. So that means, so it correctly predicted the patients have diabetes. And here 29 are there, right? 29 are correctly predicted as no. Correctly predicted as no. All right. Now, here there is 13, right? This is nothing but actually these patients have diabetes, but my model predicted as no. And here you have 18, right? Actually, these patients does not have diabetes, but my model predicted as yes. So did you understand, guys, these? What are these values? Did you understand these values, guys, now? So this one and this diagonal values are correct predictions. This diagonal values are wrong predictions. All right, guys. So whenever you compare your y-test and LPRED, your algorithm, this confusion matrix has given these data where 94 are correct predictions as yes, 29 as correct predictions as no, 13 are actually yes, but my model predicted as these people does not have diabetes. This is actually they don't have diabetes, but my model predicted as they have diabetes. So this is what this confusion matrix is. Tomorrow you will learn how do you calculate these values in a detailed manner. But for now, just remember, confusion matrix is to check how many correct predictions are there and how many wrong predictions are there out of total number of observations. All right, guys. So how can you know those are 154 prediction, 154 answers? You can just shape of x underscore test dot shape. How many you have? 154. So you have 154 questions. That means you'll have 154 answers, right? So again, y-test has those answers key paper, right? This is what confusion matrix is. Now let's see how do we calculate AUC ROC curve and what is this AUC ROC curve is. All right. So for that, what I am doing is import sklearn dot metrics as metrics. So let us put this as LCM because logistic regression confusion matrix, right? So again, we have to apply random forest and decision tree logic regression classification also to this data set, right? So just put that as LCM. That is 29. That one got typed. Now, so first FPR, comma, first of all, we have to calculate TPR. I'll also tell what is this FPR and TPR. Don't worry. Threshold is equal to LFPR LTPR L threshold is equal to NET&RICS matrix dot ROC underscore CURVE curve of Y underscore test comma L pred. L pred. Now ROC underscore AUC is equal to matrix dot AUC of FPR comma TPR. LFPR, LTPR, sorry. LFPR, LTPR, LROC underscore AUC curve. Now, if you see this LROC and AUC, you got something like 74. So, what is this FPR and TPR? And what is this 74%? All right. So, FPR is equal to false positive rate. Just remember the abbreviations, guys. Tomorrow, anyhow, you will get to know about all these things. TPR is equal to true positive rate. You can also consider as the rate of true predictions. So here predictions are how many, true predictions are how many? 94 plus 29. So you will be calculating some rate of these true predictions and you get, sorry, TPR is true predictions, guys. The rate of true predictions, and this is the rate of false predictions. The rate of false predictions. So you will be applying FPR and TPR with some sort of thresholds. So I'll tell you what are thresholds tomorrow. All right. So whenever you apply some sort of threshold while drawing a graph, you will find some amount of area under that ROC, which is nothing but called as area underscore curve. So the value of area underscore curve is 74%. If suppose AUC is equal to 1, then that means your model predicted all the correct predictions. So at that time, if suppose AUC is 1, then at that time, these values, like here you have 13 and 18, right? Those will be 0. That means the wrong predictions will not be there at all. The wrong predictions will not be there at all. For suppose, if suppose AUC is equal to 0, all the wrong predictions, that means here you have true predictions 94 and 29, right? These values will become 0 and you will have different values over here. So you can consider this as worst model. This you can consider as best model. Then if suppose AUC ROC is greater than 0.7, then that means your model predicted 30%, 70%, sorry, 70% of correct predictions. 70% correct predictions. If suppose it is less than or equal to 0.5 and in the middle of 0.7, then that means you have predicted only 50% of the data is correctly predicted. So whenever your ROC AOC curve is greater than 0.7, then you can consider that as good model. This is worst model. This is bad model. Alright guys, so your AUC ROC curve will say whether your model is the best model or a good model or a worst model or a bad model. So did you understand this guys? So and this AUC curve is purely dependent on this FPR and TPR. So FPR is false positive rate, TPR is true positive rate. Tomorrow you'll understand all these things in a detailed matter, but for now just put this theory in your minds. Understood guys? Understood this? Yes everyone. Yes. So now let's plot the graph of AUC and ROC curve. AUC and ROC curve. Plotting. So from is import matplotlib dot pyplot as plt. Plot dot tle of receiver operating characteristics. Then plot dot plot plot of f l l fpr comma l tpr comma color is equal to blue comma label is equal to AUC underscore ROC curve value is equal to percentile 0.2 F percentile LROC AUC. Next, plot dot legend. Plot dot legend plot dot x limits. You can also put x limits, guys, for x-axis, which is 0, 1. Plot dot y limits. Plot dot y limits 0, 1. Plot dot y label of true positive rate. X label is equal to false positive rate.